we're now going to take a look at integers, and we're going to be able to do several different things with integers: define them, find the opposite value, compare integers, add and subtract them, multiply and divide, and use the ever mythical order of operations. Whole numbers are defined as counting numbers including 0. So if I'm thinking about natural numbers from the previous lesson, whole numbers would be all of the natural numbers and the value 0. What's interesting is that every number has an opposite or an additive inverse. So for instance, the number 2 has an opposite of -2. The number -5 has an opposite of 5. And so this forms the group of integers. So in integers, I have my natural numbers plus 0 plus my negative numbers. An absolute value really is a descriptor of distance. And so a lot of times when we're teaching in elementary schools, we teach that absolute value is just the dropping of the negative sign, which is inaccurate, and it causes a lot of problems as students get into secondary education. So distance is a physical quantity. You can go 1 block, 2 blocks, 3 blocks. I can't go -2 blocks, which is why an absolute value is always going to be positive, is simply because it's the measurement of the distance from 0 to that value. There are some rules for absolute values. So the absolute value of any positive number is just the positive number. The absolute value of any negative number is the opposite because it's measuring the distance. And the absolute value of 0 is 0. So if I want to find the opposite of 100, that would be -100. If I wanted to find the opposite of -50, then that's going to be +50. So when we're saying opposite, we mean opposite signs. 0 is in a bit of a unique space because it's the only number that is its own opposite. The absolute value of 26 is 26. The absolute value of -99 is +99. The opposite of -10 is 10. You have to be careful though, because the absolute value of -10 is 10, and the opposite of 10 is -10. So if you look at G, I'm saying find the absolute value of -10, then take the opposite of it. When we start comparing numbers with greater than or less than, your first instinct might be to say that -10 is bigger than -5. But that's actually not going to be accurate. -5 is actually greater than -10. Because the larger the negative number, the smaller the value actually is. The integer -1 would be to the left of +3, so we would say that -1 is less than 3. And there's a common phrase that's used here is that the alligator eats the larger number. So if you're having trouble remembering which way your signs go, you can remember that it needs to be opening to the larger number. So if I'm going to use these symbols, then in these examples, I would have 4 is greater than -2, -20 is less than 0, -10 is less than -7, and the absolute value of -4 is +4. So those two numbers are considered the same. I can actually teach students to work with the number line. This is really helpful when students first start learning integers. So if I want to know 4 plus 1, that means I start at 4 and I go 1 to the right. So that would be 5. If I wanted to do 1 plus -4, I would start at 1 and go 4 to the left, which would get me to -3. So this is a common way of first teaching those concepts with integers. And then the same as if I'm at -3 and I want to go left 4, that puts me at -7. It's going to be important that before you introduce the rules for integers, you do several number line problems so that students can start to see the pattern that's going to evolve from doing this. So the first rule is if I add 2 integers with the same sign, I just add their absolute values and the answer has the same sign. If I add 2 integers with different signs, then I would find the difference between the 2 numbers, meaning to subtract, and the answer would have the sign of the larger number. So here's some examples of doing this. If I have -2 plus -8, both of those signs are negative, so I just do 2 plus 8 is 10, and it retains the sign of both numbers. If I want to work with -6 plus 8, I would subtract the two numbers. So 8 minus 6 is 2, and the larger number is positive, so the 2 is positive. In part C, again, I have two different number signs. So I'm going to do 12 minus 6, larger minus smaller. And because the 12 is negative and the absolute value of 12 is larger than 6, then the sign is going to be negative. So when we're talking about which number is larger, we're comparing the absolute value there. If I want to subtract two integers, it is the same as adding the opposite of the second number, which is why I have a minus b is the same as adding the opposite of b, which is -b. So if I look at a couple of examples here, then if I have -2 minus -8, it would be the same as adding the opposite. So it becomes -2 plus 8, because I change it to addition, and then I change -8 to its opposite, which is +8. So I get 6. Then I'm going to have in part B, I would be able to rewrite minus -7 as plus +7, which would be 10. And then in part C, I would have just a regular addition rule, so that I would be able to change that into -2 plus -6. They both have the same sign, so I'm going to do 2 plus 6 is 8, and the answer is going to be -8. Now, one of the ways my students like to remember this is change. So if I have 2 minus -8, change the subtraction, change the negative, so it's 2 plus 8. That's just an interesting thing that has always stuck with my students. Now, when I'm working with account balances, this is the most applicable concept, because as I'm deducting money or spending money, it's negative. And as I'm depositing money, it becomes positive. So here's my 5-day history for an active internet shopper. I want to then find the sum of the balances for Monday and Tuesday. So if I look at part A, on Monday I'm at 12, and on Tuesday I spend $5, so I have a balance of -5. So if I have 12 and I spent 5, I have 7 left. And then in part B, they want me to find the difference in the balances between Thursday and Friday. So on Thursday, I have a balance of -25, and on Friday, I have a balance of +20. So we're going to follow our addition rules, and we're going to get $45. So $45 was deposited to go from -25 to +40. And then in part C, what does the result say about subtracting a negative? Well, it says exactly what the rule we just used told us to do. Now, if I multiply integers, there are different rules in play. If I multiply two integers with the same sign, it's positive. If I multiply two integers with opposite signs, it's always negative. So if I have -6 times -4, that's going to be 6 times 4, which is 24, because they both have the same sign. 3 times -9 is going to be -27, because they have opposite signs. And then in C and D, you'll see the same pattern being repeated. If I'm dividing, the rules are the same. If they have the same sign, positive, different signs, negative. And it's important to realize that when we say divided by, we could also use the word quotient, because sometimes that confuses students. So we're going to look at each one of these quotients. So 32 divided by 8 is 4. They have the same side, so it's positive. 27 divided by 3 is 9. Same sign, positive. 42 divided by 7 is 6. Different signs, so it's negative. 20 divided by -5 is 4. And it's just different signs, so it's going to be negative. In E, the operation they're trying to get me to do is 8 divided by 0. I cannot divide anything by 0. That's not something that can actually be done. So the order of operations has become a very common theme on the internet because a lot of people don't understand the working from left to right mentality. So we use PEMDAS to remember this. So parentheses, exponents, multiplication, division, addition, and subtraction. What people fail to realize is multiplication and division happen simultaneously from the left to the right. They're not two separate steps. And then addition and subtraction happen simultaneously from the left to the right. So this isn't a 6-step situation, it's 4 steps. So if I'm looking at this example, 9 times 3 minus 15 times 5, there are no, there is a parenthesis. So I need to first do the parentheses. 15 divided by 5 is 3. Now I have to do the multiplication from the left to the right. 9 times 3 is 27. 27 minus 3 is 24. This is not one of the problems that pops up on the internet. This problem, though, does pop up on the internet. So first I do my parentheses. 8 minus 10 is negative 2. Then I do my exponent. 2 to the 3rd power is 8. And this is where people get messed up. Multiplication happens in simultaneous with division from the left to the right. So I'm going to do 5 times negative 2 is negative 10. And then 8 divided by 4 is 2. So this is negative 10 plus 2, which is negative 8. That's a very common area people get tripped up with. This problem has even more going on. So with parentheses, we work from the inside out. So we have to do 15 minus 2 first. 15 minus 2 is 13. So then I have 10 plus 13 left. 10 plus 13 is 23. And then I have to do this bracket before I can touch this 84 divided by 4. So now I have 84 divided by 4, which is 21. 21 minus 69, which is negative 48. And that is the concept of order of operations. The key is you don't go through the problem and do all the multiplication and then go back through and do all the division. You have to do them multiplication and division at the same time in the same step, but you go from left to right as far as prioritizing which one comes first.